electricity. Learning about electricity and its importance. Resistance of a system of resistors. Resistors in series. In an electric circuit in which three resistors R1, R2 and R3 are joined together end to end, the resistors are said to be connected in series. The total potential difference across a combination of resistors in series is equal to the sum of potential difference across the individual resistors. That is, V is equal to V1 plus V2 plus V3. You will observe that the value of the current in the ammeter is the same, independent of its position in the electric circuit. It means that in a series combination of resistors, the current is the same in every part of the circuit or the same current through each resistor. That is, V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. IR is equal to IR1 plus IR2 plus IR3. RS is equal to R1 plus R2 plus R3. Resistors in parallel. In an electric circuit where three resistors R1, R2 and R3 are joined together in parallel, it is observed that the total current I is equal to the sum of separate currents through each branch of the combination. I is equal to I1 plus I2 plus I3. Let Rp be the equivalent resistance of the parallel combination of resistors. Total current I is equal to I1 plus I2 plus I3. Therefore, by Ohm's law, V upon Rp is equal to V upon R1 plus V upon R2 plus V upon R3, or 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Thus, the reciprocal of the equivalent resistance of a group of resistance joined in parallel is equal to the sum of the reciprocals of the individual resistance. Heating effect of electric current. We often observe this in our everyday lives. For example, an electric fan becomes warm if used continuously for a longer time. Electric press, oven, toaster, heater, etc. are some examples where electric energy dissipates in the form of heat. It happens only if the electric circuit is purely resistive. This is known as the heating effect of electric current. This is an electric press. A press contains resistance coil which when connected to power supply gets heated. Let P be the power supply to press. I is the current flowing through resistance coil R and develops potential difference V. Let T is the time during which the charge Q flows across. Therefore, work done in moving the charge Q will be VQ. The source must supply energy equal to VQ in time T. Hence, the power input to the circuit by the source is P is equal to VQ upon T. As Q upon T is equal to I, therefore, P is equal to VI is the energy supplied for unit time. Now, the energy supplied to the circuit by the source in time T is P multiplied by T. That is, by putting value of P, the required energy will be VI into T. What happens to this energy expended by the source? H is equal to VI multiplied by T. As V is equal to IR, H is equal to I square R into T. I square RT. This is known as Joule's law of heating. The law implies that the heat produced in a resistor is directly proportional to the square of current for a given resistance, directly proportional to resistance for a given current, and directly proportional to the time for which the current flows through the resistor.
Summary. Electric current is expressed by the amount of charge flowing through a particular area in unit time. The electric current is expressed by a unit called ampere, A, and an instrument which measures electric current in a circuit is known as ammeter. The law implies that heat produced in a resistor is first, directly proportional to the square of a current for a given resistance. Second, directly proportional to resistance for a given current. And third, directly proportional to the time for which the current flows through the resistor. That is all in this chapter. Enjoy learning.